Hello everyone, welcome back to mahasarkar.co.in. In today's video, we are going to start second lesson and second lesson's title is Fluid Dynamics. In a 11th standard, you have learned about the properties of solids. Now, in this lesson, strictly we are going to learn about the fluids. So, before starting with actual lesson, few basic things that we require to revise. What is fluid? Then water, oil, if I pour on plane or inclined surface, it will not stop there, it will move. So instead of calling it will move, I will call it is flowing. So the substance which can flow, the substance which can flow is called as what? Fluid. Some important properties of fluid that what we have learned already are that ideal fluid is expected to be incompressible. Ideal fluid is expected to be what? Incompressible. The ideal fluid should be expected to be non-viscous. And ideal fluid, the flow of that fluid should be irrotational. Flow of fluid is what? Should be irrotational. And finally, that fluid should possess all the properties that are related to the structure of liquid plus gas. Means the intermolecular force of attraction between them is sufficiently smaller than that of what? Solid. So when we discuss fluid, this property should be there. But the fluid which we use in a practical, instead of calling ideal fluid, I will call what? Practical fluid. Then practical fluid is compressed at higher level. It is what? Compressed at higher level. It has fixed volume, but it occupies the shape of container. Because of that, it has to undergo the stress we called shear stress or shearing stress. It has to undergo the shear stress, that is change in the shape should be takes place. Okay. Now these are the basic things what we need to recall about the fluid. When we discuss about the fluid, some important properties of the fluid that what we are going to learn in this lesson are: first property is pressure. First property is what? Pressure. Then the second but very important property is surface tension. Second important property of the fluid that what we are going to learn in this lesson is what? Surface tension. And the third important property that we are going to deal in the lesson is about viscosity. All these three properties combinedly will be considered as what? Fluid dynamics. Here, basic definitions we require. First is hydrostatics. Word hydro will consider for fluid and static at what? Rest. So, study of fluid at rest is called as what? Hydrostatic. So, these are some basic things that what we need to recall. So, let's start the first article, first important characteristics, that is what? Pressure. Now, about the pressure, you have learned in the 9th standard. You have learned Archimedes principle also, you have familiar with the buoyant force also. If you jump into the water, what is happening? Water surface is exerting force on you which is in upward direction. That means water surface is trying to exert force against your weight. Because of that, you can easily float on the water surface as your weight goes on decreasing. Or in other words, there is a loss of weight when you jump into the water. So why it is happening? Or suppose I have one container and in that container I have filled the liquid, water suppose. And now what I have done is I have made small hole at any point on the container. So without applying any force, that water will start moving through the container. Why it is happening? Because every particle of water is exerting force on the wall of container. That force which is exerted by that particle of the material, we call it as what? Thrust. We call this is what? Thrust. We call this is what? Buoyant force also. Okay. This thrust or buoyant force is nothing but what? Actually the force. So this force is always acts on the given surface of the container in which liquid is filled. So if you want to find out the term pressure, then we are going to learn two things. First is this force, and second is what? The surface area on which that force is going to act. And therefore the basic definition of pressure now we are going to learn. Okay, so let's learn the pressure. Pressure is defined as the force acting normally. Here the word normally means what? Perpendicular to the given surface of fluid is called as which force? What term? Pressure. The force acting normally perpendicular to the given surface of fluid. So here as I said, fluid is nothing but what? Combination of liquid and gas. Therefore, pressure can be written as pressure is equals to force upon area. It is also can be equal to thrust upon area. So pressure P equal to F upon A. So from this formula, it's simple to find out SI unit. SI unit is, we know that we calculate force in what? Newton. Area in a meter square. So SI unit is Newton per meter square. CGS unit is Newton is converted into what? Dyne. Meter is converted into what? Centimeter square. So CGS unit is what? Dyne per centimeter square. If I want to find out the dimensions force, what are the dimensions of force? Can you recall? Yes, it is M1 L2 T minus 2, sorry, M1 L1 T minus 2, then divided by area, so it is L2. So what will be the final dimensions? Check out. M1 L1 upon L2 is what? L minus 1, and this T minus 2. So these will be the total dimensions of the pressure. Okay. Remember this Newton per meter square, 1 Newton per meter square is also equal to Pascal, as Sir Pascal had given one important law related to pressure. Therefore 1 Newton per meter square is also equal to taken as what? Pascal. If I want to write the symbol, then symbol is Pa. Okay. Now we will learn pressure due to liquid column. In this case, what we are going to assume is that liquid is filled in any container. Okay. So few things about the liquid that we will write. So let M be the, not M, say rho be the density of the liquid which is filled. Now what we consider, that liquid has made its own cylinder. So this is the cylinder. पण त्या लिक्विडचाच इमॅजिनरी सिलेंडर आहे. इमॅजिन करा तुम्हाला लिक्विड मध्ये एक इमॅजिनरी सिलेंडर क्रिएट केला. सो लेट H बी द height of that imaginary cylinder. Remember this is nothing but the cylinder made up of the same liquid. So M is the mass of that cylinder. M is what? Mass of the cylinder, and A be the area of cylinder, area of cross section for that cylinder. Okay. Now this cylinder is exerting force on the remaining layers of the liquid. For example, this is cylinder. This cylinder is trying to exert force on remaining layers of the liquid. Now because of that, this cylinder will exert force in a downward direction, and we know that the force exerted by that cylinder in a downward direction will be nothing but the weight of that. So basic things what to be written here the force exerted by cylinder, the force exerted by cylinder on the bottom of vessel is nothing but weight of that cylinder. Is nothing but what? Weight of the cylinder. And we know that, so therefore this force F is equals to mg. Force is equals to what? M into g. Okay. Now, so if I apply the pressure exerted by this cylinder of liquid on this surface of the container, so it will go in a downward direction. Imagine करा की जर मी हा मार्कर जर डिप केला, तर डिप करताना मार्कर चा सिलेंडर आहे and this cylinder is going to fall here like that. So it is falling due to gravity. So it is exerting force which is nothing but what? Weight of the cylinder, and this much of area of that cylinder will be acting, and the same force will act over that particular area. So I will say here, by definition, pressure exerted by liquid by that column of the cylinder will called liquid column. Pressure exerted by what? Liquid column is P equal to force upon area. What I said, what is force? Force is mg upon area. Okay, let this is equation number 1. Now, what is the basic definition for density? Density of liquid is nothing but mass upon volume of that cylinder. So density of liquid and density of cylinder can be the same or will be the same. So here, according to this formula, we will get mass equal to rho into V. Mass is equals to what? Rho into V. This is the cylinder. What is the volume of cylinder? Pi r square into h. Na? Volume of cylinder will be pi r square into h. But pi r square is nothing but area. So it is like rho into area into height. So this is equation number 2. So substituting 2 in 1, we will get P equal to rho A h into g divided by A. So A get cancelled. So P equal to rho hg. Pressure exerted by fluid column at rest is always equals to what? P equal to rho hg. Okay. From this we can say that pressure is directly proportional to density, pressure is directly proportional to depth or height of that liquid column, okay, and directly proportional to acceleration due to gravity also. So if planet is changed, the acceleration due to gravity will change and corresponding pressure of that column acting on that surface is also going to what? Change. Okay. Now, when we discuss this, it is not enough to explain this pressure. This is not, I will say, it is not the total pressure. When or why it is not total pressure? Because we know that this jar or this container is not present, or it is not only containing the air. Above this, large number of atmospheric particles are there. As we know that Earth is made up of large quantity of atmosphere, and that all the atmosphere consisting of what? Large number of gases. And because of gravity, their weight is also directed what? Downward. So some gas particles which are present in this core also add some extra force. They add some what? Extra force. This extra force adds some extra pressure also. They add some extra pressure. So what we call this extra pressure? We are going to call that extra pressure as atmospheric pressure. We are going to call it as what? Atmospheric pressure. Atmospheric pressure. So what is atmospheric pressure? The additional pressure exerted by molecules present in the atmosphere are called as what? Atmospheric pressure, indicated by P naught. Okay. Therefore, if I know this pressure which is due to fluid column and some additional weight, so we will get one more term called as what? Absolute pressure. We will get what? Absolute pressure. So remember, absolute pressure is the sum of atmospheric pressure, sum of what? atmospheric pressure and pressure due to fluid column. Pressure due to fluid column. So I can say absolute pressure P is equals to P naught plus fluid due, this what? Say PA, P absolute is equals to P naught, that is atmospheric pressure, plus rho Hg. Okay. Difference between these two, or I will write PA minus P naught is equals to rho Hg. So this difference is called as gauge pressure. This difference is called as what? Gauge pressure. I hope you understood this. What we have done is, in a very simple words, we have calculated pressure exerted by this fluid column on the surface. Okay. So that fluid column is nothing but imaginary cylinder we have taken. If you would not have taken, मी काय केलं असतं, डायरेक्ट अख्खं चापकं लिक्विड त्या सगळ्यांच्या मॉलिक्युलचा फोर्स इथं ऍक्ट झाला असता. सो लिक्विडचे टोटल मास आणि टोटल व्हॉल्यूम सिलेंड्रिकलच असतं. ओके. सो ते इमॅजिनरी हा सिलेंडर इमॅजिन न करता मी अख्खा जारला इमॅजिनरी सिलेंडर कन्सिडर केला असता तरी सुद्धा सेम डेरिवेशन मला मिळालं असतं. सो वन कॅन क्लिअर दॅट pressure is not depend upon the surface area, remember. Okay, it depends upon the height, it depends upon the density, and it depends upon what? Acceleration due to gravity. Again, atmospheric pressure is the pressure which is contributed by some additional particles which are present in the air. Okay, and then atmospheric pressure plus this pressure due to fluid column is going to give us absolute pressure. Difference between absolute pressure and atmospheric pressure is called gauge pressure and given by PA minus P0 is equals to what? Rho Hg. If this H is suppose like if this is the container and इथं एक आहे, याची height h1, याची height h2, so instead of h sometimes you can write h2 minus h1 or h1 minus h2 into g, depending upon the condition what is given there, this formula will be changed. I hope you understood today's article. Thanks for watching mahasarkar.co.in. See you again. Have a nice day.